Oh no 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 no.
Everyone, so welcome to my channel Fairy Tutors. So in the last class we seen about the spectrum. So in that spectrum we are discussed about the relation between wavelength and frequency. So here I am going to explain from visible spectrum and electromagnetic spectrum. So let us see what is visible spectrum. So generally in our daily life we observe the rainbow. So in rainbow there are beautiful 7 colors are there. Yes sir. In those 7 colors we can simply write as Vidya. So these are the 7 colors Vidya. That means violet, indigo, blue, green, yellow, orange. So these 7 colors are present in the rainbow. Okay, so that means here all the 7 colors are continuously arranged without any space between them, without any gaps between them. So they are arranged in a continuous manner. So if you are observed in picture, violet to red color, each color has its characterized wavelengths, frequency. So there contains different wavelengths. Each color has its own wavelength and own frequency. So that's why we can say that violet color has short wavelength and red color has long wavelength. Violet color has short wavelength and red color has long wavelength. So the remaining colors are present between violet to red color, right? So and moreover all these colors, all the 7 colors are visible to the human eye. So for the human naked eyes all the colors are visible. So that's why this light is said to be visible light. This light is said to be visible light. And in this visible light, the entire range of wavelengths, which are visible to us are said to be visible spectrum. So the entire range of these wavelengths which are visible to our naked eyes are said to be visible spectrum. Right? So here the question is there any other wavelengths more than visible light or visible wavelengths? Just imagine, is there any other wavelengths? Is there any wavelength more than red? Is there any wavelength less than violet? Yeah, definitely. So the wavelengths are present less than violet and more than red. So that means other than visible spectrum there are different wavelengths are there. So these entire range of wavelengths, the entire range of these wavelengths other than are including visible spectrum is said to be electromagnetic spectrum. EMR, electromagnetic spectrum. So this is simply called as EMR. So actually an electromagnetic wave has wide varieties of wavelengths. The entire range of these wavelengths are called electromagnetic spectrum. So let us see what are the wavelengths are present here, or what are the wave colors, what are the names are given to these electromagnetic spectrums. So let us see. First one is gamma rays. Gamma rays, X-rays, UV rays, visible light, and IR radiation, that means infrared radiation, microwaves, and finally radio waves. So these are the entire range of electromagnetic spectrum. So in this electromagnetic spectrum, we are only visible, or we are only sensible to visible light. We are only sensible to this visible light. So the range of wavelength is 400 nanometers to 700 nanometers. 400 nanometers to 700 nanometers. This is the wavelength only sensible to the human naked eyes. So remaining all wavelengths does not observed by the human eyes, right? So our eyes are only sensible between 400 nanometers to 700 nanometers. So this is visible spectrum. In this visible spectrum only we can observe entire this world. So all the colors we are observing between 400 to 700 nanometers. Even the rainbow is also present in this range, right? So this is about the entire range of electromagnetic spectrum. And if you are observing here from gamma rays to radio waves, the wavelength is increased. Here what happened? Wavelength is increased. That means we are arranged this electromagnetic spectrum in the ascending order of their wavelength. That means at gamma rays the wavelength is very short. From gamma rays to when we are moving right side, then the wavelength is gradually increases. Finally the more wavelength is present at radio waves. So if the wavelength is gradually increasing, means what happened to the frequency? Already in the last video we seen about the relation between frequency and wavelength. What is that relation? C is equal to nu lambda. We seen this. C is equal to nu lambda. So here the relation between nu and lambda is inversely proportional. And C is a constant, that is 3 into 10 power 8 meter per seconds. It is the velocity of light in vacuum, right? So nu is inversely proportional to 1 by lambda. That means frequency is inversely proportional to wavelength, right? So that's why here if you are writing here wavelength is increasing, then what happened to the frequency? Gamma rays has the short wavelength. Then what about its frequency? Frequency is more. So they have more frequency. Because we have the relation between wavelength and frequency. Wavelength is inversely proportional to the frequency. If wavelength increasing means frequency decreased. If frequency decreased means wavelength increased. Right? So this is about the electromagnetic spectrum. In this electromagnetic spectrum, we are sensible to 400 nanometers to 700 nanometers. So this is said to be visible spectrum. Right? So let us see. Suppose you have an iron rod we are heating that iron rod continuously. Do you observe any color changes? If you are heat the iron rod, the color changes, did you observe or not? Yeah, absolutely you can observe when you are heat the iron rod continuously. Whenever the temperature is increased, its colors are changed. First you can observe the, whenever the temperature is low, you can observe the red color. So if the temperature is continuously increasing means there are various colors are observed. So finally you can get white color also at high temperature. Right? So and the question is, if one color is visible, is there any color is visible to us? More than one color is visible to us? No. Because when one color is visible to us, because that color's intensity is more than the remaining colors. So that means that color will dominate the remaining colors because of its intensity. Right? That's why we can observe only one single color. Okay. So after that, Max Planck so he was broke the continuous energy tradition. So that means up to the Max Planck, so everyone thought that the energy is in the continuous form. But Max Planck said that energy is not in a continuous form. It is energy is in the form of or in multiples of, it is in the multiples of h nu. It is in the multiples of h nu. So example, for example, like h nu, 2h nu, 3h nu, and so on. So like that the energy is released emitted. So energy is not in a continuous form. The energy gained or lost in a discrete manner, not in a continuous manner. Discrete values not in a continuous manner. So like that he was given, and he was given the relationship E is equal to h nu. E is equal to h nu. This is very important relation here. E is nothing but energy. H is Planck's constant. Planck's constant. H is Planck's constant. Its value is 6.626 into 10 power minus 34 joule seconds. Planck's constant value is 6.626 into 10 power minus 34 joule seconds. So here E is energy. The relation between energy and frequency is nothing but E is directly proportional to nu. That means frequency increasing means energy also increased. So if you are observed in WIBGER, red color has more wavelength, that means less frequency. Less frequency means red color has the less energy also. So if you are observed the blue color wavelength is less than the red color, but its energy is more than red color. So like that the relation is obtained here by the Max Planck. According to Max Planck, he was given that energy is gained or lost in a discrete values, not in a continuous manner. So like h nu multiples. So here what is h? H is nothing but Planck's constant, and its value is 6.626 into 10 power minus 34 joule seconds. Right? So this is about the Max Planck's value. And one more thing is during the Diwali season we use from fireworks. Some fireworks we use, and from those fireworks there are different colors are released. Yes or no? There are different colors are released. So how they are released? How from the fireworks there are different colors are released? So when they are exploded, because we have a small example here. Take a pinch of cupric chloride take a pinch of cupric chloride and it has to be mixed with hydrochloric acid. So take a pinch of cupric chloride in your watch glass and add 2 drops of hydrochloric acid and make it as a paste. Make it as a paste. So this paste has to be taken on a platinum loop and you have to introduce it into the non-luminous flame. So observe the color changes. What is the color of flame is releasing when you are heating or you are introducing the cupric chloride to the non-luminous flame. And at the same time, another example is there when you are taking the strontium chloride. Strontium chloride. So this has to be made same as paste with the HCl, hydrochloric acid. So this also you have to be introduced to the non-luminous flame. So there you can observe the color changes, which type of flame is released. So here when you are use the cupric chloride, you can obtain or you can get the green color flame. So when you are use the cupric chloride, green color flame will be emitted. And when you are use the strontium chloride, the crimson red color flame will be emitted here. So when cupric chloride is used, which color is produced? Green color. When strontium chloride is used, crimson red color will be produced. And in our daily life, so the street lights are producing yellow light because of sodium vapors. Here what happened? Sodium vapors produce yellow light. Sodium vapors are producing yellow light. So here there are some differences are there. From each element they are producing different colors. So cupric chloride green color, strontium crimson color and sodium yellow color. So why different elements are given different colors? That is, each color has its own characterized wavelength. So these wavelengths are said to be line spectrum. These wavelengths are said to be line spectrum. These wavelengths are said to be line spectrum. The lines in the atomic spectra are useful to recognize or detect the unknown elements. So each line represents one wavelength. So the wavelength is regarding to the specified element, right? So this is about the line spectrum. In the next class we are going to see about the Bohr's atomic model. Thank you.